Welcome to the final webinar in the 2020 Virtual Summer Learning Series for Elementary Mathematics Educators. My name is Emily Bruning, and I am the Elementary Math and Science Specialist at the Indiana Department of Education. This slide deck is available for you on the Mathematics Standards page at doe.in.gov/standards/mathematics under Professional Learning. Throughout the Virtual Summer Series, we have two purposes. First, we want to explore high-quality math resources that are aligned to the Indiana academic standards to aid in improving teaching and learning of mathematics for all students. What is important to note here is that high quality does not equal complex. Our goal is to explore resources and routines that do not require a heavy lift for educators to implement. Second, we hope that you will discover for the first time or learn ways to refine your current understanding of ways to integrate the specific resource into your instructional routines, both virtually and in person. You will have the opportunity to try a few out, so I encourage you to pause the webinar to work through the task, reflect on the work, and consider your own classroom implications of the instructional routine. Before we begin, let's talk a little about wait time. Research shows the average length a teacher waits is 0.9 seconds. The fastest 100-meter sprinters in the world run at 10 seconds. The world record is under 10 seconds, and that is fast. We should at least be able to offer our students 10 seconds to consider responses that require deeper thinking. You know your students best and how much time they need, but I suggest starting with at least 20 seconds in elementary. You can work up longer times and build students' stamina, but it requires practice. I would also suggest using a visual timer for both you and your students. Ask students to be respectful of each other's think time and not share their thinking until the timer is done. Students need time to process the information on their own before considering the thinking of others. Some guiding questions may include, what do you notice? What makes all the items alike? What makes them different? Which one doesn't belong? Can you share your reasoning to justify your answer? By now, most of these questions should sound familiar. Once the timer has stopped, have students share out. If your students have never done a which one doesn't belong before, I would encourage you to start with something easily accessible and non-math related. Let's try one together. Remember to think first, pause the webinar to answer the question, which one doesn't belong? When you have your response, join me back on the webinar. Here are a few responses from this task. Top left doesn't belong because the puppy's ears are pointed up. Bottom left doesn't belong because one puppy's eyes are closed. Top right doesn't belong because someone is holding the puppies with their hands. Bottom right doesn't belong because there are only two puppies. Let's try a primary elementary task. Remember to think first. Pause the webinar to answer the question, which one doesn't belong? When you have your response, join me back on the webinar. Here are a few responses from this task. Top left doesn't belong because it has curved lines. Bottom left doesn't belong because there are two shapes. Top right doesn't belong because there is no red outline. Bottom right doesn't belong because there is no color fill. Let's try an upper elementary task. Remember to think first, pause the webinar to answer the question, which one doesn't belong? When you have your response, join me back on the webinar. Here are a few responses from this task. Top left doesn't belong because the groups are identified with circles. Bottom left doesn't belong because it is multiplying the same number. Top right doesn't belong because it is adding. Bottom right doesn't belong because the visual is represented with circles instead of stars. I have linked the Which One Doesn't Belong website with free classroom timers of all varieties to practice wait time for these tasks and others. Let's consider one more. I'm going to show you real responses from elementary students and what it reveals about their mathematical knowledge. I like to present this because it shows how you can use Which One Doesn't Belong as a formative assessment. You can learn so much about your students from these tasks. The third grade student decides the top left doesn't belong, saying it is the only whole number. I can see that the third grade student understands fractions because they see the top left as 4 over 4 or a whole number. The kindergarten student decided the bottom left doesn't belong, saying there are no dots on the bottom. They are just seeing the visual pattern of the dots. They are a perceptual subbetizer, but not yet a conceptual subbetizer. The second grade student decides the top right doesn't belong, saying this has the biggest numbers. They saw the quantity and noticed that either the 6 is the largest number represented or the total is the largest sum represented. The first grade student decides the bottom right doesn't belong, saying this has the smallest number. This student does not quite understand the concept of 0. They see the 2 dots as the smallest number, but are discounting the 0 on the bottom left. These tasks are great exit tickets to gain that information you need to inform your instruction. The Which One Doesn't Belong instructional routine was inspired by the Math Twitter blogosphere, or MitBoss, and Christopher Danielson, who wrote Which One Doesn't Belong, a Shapes book, and hosts Talking Math with Your Kids on Twitter. Christopher Danielson saw a need for math books that give opportunity for rich conversations and challenge students in the same way that literary stories do. He structured the book around things elementary teachers have to teach. For example, there is a polygon page. Many things can be pulled from it, but there is only one polygon and its characteristics providing a teaching opportunity. I have linked resources to Christopher Danielson's book and blog in the notes section of this slide deck. Steve Wyborny had a similar idea in 2015 called imposter sets. Imposter sets provide an opportunity for students to investigate and compare and contrast math concepts. Students are tasked to determine the imposter by looking for the math property that is shared by the other 3 numbers. It is possible for multiple numbers to be the imposter based on the math property the student determines. In imposter sets, you ask students, how do you define and defend the imposter? Instead of simply, how did you find the imposter? There are many similarities between imposter sets and Which One Doesn't Belong. Same but Different is another similar instructional routine. It provides a collection of images to encourage grayscale thinking, or the ability to see the world as having middle ground versus black and white. For example, there is not just short and long, but many lengths in between. Categorical thinking, or the ability to attend to the features of things and how to connect something new to something we are familiar with, and helping students build a network of ideas for learning and thinking about math. I have linked the imposter sets and the Same but Different website in the notes section of the slide deck. The Which One Doesn't Belong website is dedicated to providing thought-provoking puzzles for math teachers and students. The routine offers visual puzzles that encourage an opportunity for all students to engage. There are no answers provided, as there are many different and correct ways of choosing which one doesn't belong. There are 4 different categories on the website, and I'm going to go through each one to show you what each category entails. The first is shapes. You will see which one doesn't belong puzzles with actual shapes, but you'll also see puzzles with money. This is where you will also find some of the more easily accessible which one doesn't belong puzzles, like this banana one or the puppy one I showed earlier. The next is numbers. Here you will find which one doesn't belong puzzles with actual numerals. You will also find things like clocks and other measurement content. The next is graphs. Being completely transparent on the actual which one doesn't belong website, you won't find much relevance to elementary content. The which one doesn't belong graph puzzles are geared toward secondary students. But that doesn't mean there is no content out there for you. Here I have some examples of which one doesn't belong graph puzzles created by other math organizations and educators. These can easily be found by searching the hashtag WODB on Twitter. There's a whole which one doesn't belong community where teachers are posting puzzles all the time. Lastly, there's incomplete sets. This again is geared more towards secondary students, and there isn't much available on the Which One Doesn't Belong website for incomplete sets. However, it is very simple to take a pre-made Which One Doesn't Belong puzzle from the website and create your own incomplete set by removing one of the options. These are great for challenging your students after they are familiar with Which One Doesn't Belong puzzles. For in-person teaching, use Which One Doesn't Belong as warm-ups for just-in-time teaching. Students can write their response on a Post-it and place it on the board or smartboard. You can give students a sentence stem to help, like the number blank does not belong because. Some students feel uncomfortable to participate with tasks like these simply because they don't have access to common vocabulary or language like the one in the lower left, or using color or a symbol can help make this accessible to your special populations that may have language barriers or other special needs like color blindness. You can use something like this to accommodate those students. Students have the choice to say, the red one doesn't belong, or letter D doesn't belong. Validate every student answer, even if it's not mathematical in nature. In the example on the right, the teacher was recording student responses, and students were saying things like, it looks like a fidget spinner, and it looks like the letter Z. Remember when I mentioned grayscale thinking and categorical thinking? Those answers are coming from students' prior knowledge and they are making connections. Our goal is to build a safe space to share mathematical thinking, and we do that by validating student thinking. You can then use some skillful prompting and questioning to orient their reasoning to serve the mathematical goal. Also ask purposeful questions. Which one doesn't belong puzzles encourage opportunity for deep thinking. Some questions to consider are, what justification could you use to say that blank doesn't belong? What other justifications could student A have used to decide that blank doesn't belong? How can students A, B, and C all be correct even though they each chose a different value? I encourage you to vary these within the progression of your lesson, not only as a warm-up at the beginning of your lesson, but also as a brain break in the middle of an intense lesson where students may need a break. You're still incorporating the standard or skill, but in a more interactive and engaging way. You can also use these at the end of your lesson as a formative assessment to inform your instructional decisions for later lessons. To extend the learning, have students create their own. You can give students the content or provide a lesson on a new skill and have the students come up with a which one doesn't belong puzzle that matches the content you're teaching. Teachers can also modify which one doesn't belong puzzles to adapt to the current objective and skills, or even branch out and create your own which one doesn't belong puzzles. I'm going to be completely transparent and forewarn you that Desmos is marketed towards secondary educators and students. Most of the pre-made activities on Desmos are not appropriate for elementary students. With that being said, I would encourage all of elementary educators to check out the Desmos Activity Builder. This does have value for any educator. If you go to student.desmos.com and type in the code B958FA, you can see what Desmos is all about. Consider pausing the webinar to navigate to the website and then join me back for more information. As you navigate through the screens, you can see what the student sees. I've linked this Desmos activity in the notes section of the slide deck. Teachers can copy and paste the activity to their own Desmos and edit and customize the entire activity. Teachers will see a screen similar to students, but you will be able to see all the students' responses and progress. Teachers can create virtual Which One Does It Belong puzzles by simply inputting the image of the puzzle and adding different elements to customize the lesson for your students to show they will respond to the puzzle. There is so much you can do with the Activity Builder to create virtual tasks for your students. Nearpod is an easy way to make your lessons interactive. You can use what you already have, like Google Slides, PowerPoints, photos, or videos. These lessons give students a chance to show what they know and add real-time check-ins for understanding. Each lesson is completely customizable to best fit your needs. It's great for virtual teaching because you will know where your students are every step of the way through the real-time function of the program. You can also use the reports Nearpod generates to inform your instruction. Similarly to Desmos, there is a student view and a teacher view. Consider pausing the webinar and going to join.nearpod.com and enter the code ASEJC to see what students would see. As you navigate through, you can see the many tools students have to use to respond to the task. In the teacher's view, the teacher will see what students have submitted and what students are still working on. Once a student has completed a task, you will see their response. There are 3 ways to teach with Nearpod, and I am showing you the live participation, which can work well with both in-person and virtual teaching as the teacher controls the pace of the lesson and students participate on their own individual devices. There is also self-paced, where students can work at their own pace and is ideal for virtual settings and for those students who cannot make your live sessions. Nearpod also allows for in-person teaching by projecting the lesson in your classroom and facilitating a collaborative environment. I have linked this Nearpod lesson in the notes section of the slide deck. If you are a Pear Deck user and have access to the premium features, you can explore the Pear Deck draggable slides. If you are not a Pear Deck user or do not have access to the premium features, a similar task can be created in Google Slides. I have linked this Google Slides template in the notes section of the slide deck, and you will be forced to make a copy for access. Simply copy and paste images to the template to create your own Which One Doesn't Belong task. Once you share with students, students can move the colored blue dot to their choice, which will lead to some great mathematical discourse while students justify their choices. The Math Learning Center offers great free virtual visual models with so many useful manipulatives. It is super easy to make Which One Doesn't Belong task right within the app. There are number frames that you can represent in 5, 10, 20, or 100. There are many different colors, shapes, and customizable features to make each number frame Which One Doesn't Belong unique and to fit the needs of your class. There are number pieces, which are basically base 10 blocks. Using this with which one doesn't belong can help build a deeper understanding of place value and students' computational skills. There are fractions. You can represent fraction bars or fraction circles with denominators from 1 to 100. Like the others, this app has many customizable features to fit the needs of your students and instructional goals. There are money pieces that help students visualize money values and relationships. Each app has text and equation capability, so that is an added feature on all the apps to add another element to the which one doesn't belong puzzle. Finally, there are pattern shapes, which are pattern blocks. There are many ways to manipulate the pattern blocks to create a which one doesn't belong that fits your instructional needs. This resource is linked in the notes section of the slide deck. Now that we are familiar with the in-person and virtual opportunities of a which one doesn't belong routine, I'd like to share a few tips that will help to enhance the teacher and student experience. Each object in a which one doesn't belong set has at least one reason not to belong. There is not one right answer. With that in mind, it is important to validate all responses. Saying yes does not mean you are right. Rich math talk depends on students feeling safe and their ideas valued. If a claim is true, it is correct. Press for precision. Students will need help learning to express their ideas precisely. Ask questions to ensure that you and your students understand the exact differences or similarities under discussion. Introduce vocabulary when students need it. Students often notice properties they don't know names for. Use these opportunities to introduce vocabulary. And give students time. Make sure students have the time and space to do their best thinking. No hands raised, no talking, no pressure for about a minute before. Specific math content will vary depending on how you're using the puzzles and your instructional goal. A great resource to help you with planning is the Math Framework. The Math Framework offers a looking back and looking ahead section that shows you the vertical alignment of standards. Utilizing this part of the framework can help you choose tasks that best fit your students' needs and recognize the prior knowledge needed that can be used to build understanding of the grade level target. Let's consider a second grade teacher using this which one doesn't belong to get a gauge on students' current understanding of the value of coins and collections of coins. By intentionally choosing this which one doesn't belong puzzle, the teacher has an opportunity to draw upon students' prior knowledge of 1M3. You could listen for vocabulary use, how they count the collection, and their reasoning. To further engage prior knowledge and gain an understanding of what your students know, ask that important math question, what do you notice? One could argue that every process standard is embedded within a which one doesn't belong puzzle, but I have identified a few that this instructional routine encourages students to use. In Reasoning and Explaining, Process Standard 2 describes mathematically proficient students make sense of quantities and their relationships in problem situations. They bring two complementary abilities to bear on problems involving quantitative relationships: the ability to decontextualize, to abstract a given situation and represent it symbolically, and manipulate the representing symbols as if they have a life of their own without necessarily attending to their reference, and the ability to contextualize, to pause as needed during the manipulation process in order to probe into the reference for the symbols involved. Process Standard 3 describes mathematically proficient students make conjectures and build a logical progression of statements to explore the truth of their conjectures. They analyze situations by breaking them into cases and recognize and use counterexamples. They organize their mathematical thinking, justify their conclusions, and communicate them to others, and respond to the arguments of others. In Seeing Structures and Generalizing, Process Standard 7 describes mathematically proficient students look closely to discern a pattern or structure. They step back for an overview and shift perspective. Process Standard 8 describes mathematically proficient students notice their regularity in mathematical problems and their work to create a rule or formula. They maintain oversight of the process while attending to the details as they solve a problem. They continually evaluate the reasonableness of their intermediate results. Which One Doesn't Belong promotes a respectful learning community by creating a culture of valuing students as thinkers, reasoners, listeners, justifiers, and doers of math. Diverse thinking is valued. Each Which One Doesn't Belong set is designed to be interpreted in a variety of different ways, and because all answers are correct, students naturally shift their focus to justifications that spark deep mathematical thinking and discussion. Some of what students learn is considered just in case. Content is sometimes taught just in case they need it later in school or the workplace. Once students determine a college major or start their first job, they begin learning just-in-time content. The things you need to learn when you need to learn them. Just-in-time learning is highly motivating. You begin to understand that you must learn some things before you can apply your learning. Which One Doesn't Belong allows for just-in-time teaching, accessing content that is needed to accelerate the grade level content coming up in the lesson. Students are actively engaged in reviewing material, and it gives the educator information on students' existing knowledge before teaching begins. Instructional routines are important for teachers to establish with their students. They help build consistency and a level of predictability that students often crave. When students are familiar with an instructional routine, they are able to focus on their thinking and not on the next step of the process, or on figuring out what question they're supposed to be answering. Instructional routines also benefit the teacher. Establishing instructional routines enables teachers to focus on their questioning and allows them to focus on student understanding. They allow teachers to listen to students' thinking and not for the right answer. Each school year brings its own unique set of challenges. The 2020-2021 school year will be no different. It is imperative that we focus on the acceleration of learning for our students, which is loosely defined by teaching and learning more than 1 year's amount of content in a single year. In order to do that, we must make a commitment to teaching grade level content while strategically and intentionally drawing on and reviewing prior content. Which One Doesn't Belong will support accelerated learning in several ways. Setting goals sets the stage for instructional decisions. Teachers must consider broader goals as well as the goal of the lesson. You should be able to answer questions such as, what is to be learned? Why is the goal important? Where are the students coming from? Where do students need to go? And how can learning be extended? To implement tasks that create student exploration and sense-making, encourage students to ask questions and give time for exploration of new content by using a variety of methods and strategies. Talking and sharing are essential to effective instruction. Explaining ideas, listening to others, and asking questions help students make sense of their ideas. Provide students with opportunities to share ideas, clarify their understanding, and develop convincing arguments. By talking and sharing, you will advance the mathematical thinking of the entire class. When you are able to scaffold classroom discussions, you aid students in making connections between representations and mathematical ideas. You support sense-making, and you encourage students to explain their reasoning. It is important to assess student thinking and understanding through formative assessments in an ongoing manner. Eliciting and using evidence of student thinking, you are better able to access learning progress and make instructional decisions during the lesson. Be sure to pose questions and answer student questions that provide information about student understanding, strategies, and reasoning. Finally, be sure to use evidence of student thinking to determine next steps of instruction. In the notes section of the slide deck, I've linked 2 great resources for best practices for instructional reentry. I would recommend using these resources as you plan for instruction. Copyright gives exclusive rights to the original work. Any work that is copyrighted is owned by a specific person, and you must gain permission to use the work. Educational fair use is an exception. It provides limitations without seeking permission from the copyright. Teaching falls under educational fair use. In its simplest form, you can use work that is copyrighted as long as it is not for profit or commercial use. Is suitably appropriate, the work stays intact and original to its use, and its intended use will not affect the copyrighted material's value. This does not discount credit. You must still source and give credit where it is due. For example, this flowchart was adapted with permission from Art Class with LMJ. She created an educational fair use flowchart that I wanted to adapt to support math teachers. So I reached out to her and was given permission by her to adapt and use the resource in this way. But I'm giving her credit by linking the source on my document. Use the flowchart to figure out what path to take when using work from outside sources. Some basic rules of thumb include: if you did not personally create it, assume that it's copyrighted. If your use of the work will result in profit, distribution, or personal gain, you should always get permission first. If the work is not being used outside of class, you are typically safe, but it's always best to have the original resource cited and available. Thank you so much for joining me today. You can scan the QR code by opening your iPhone camera and holding it up to the screen or another QR reader app. You can also click the Here link on the slide deck to fill out a short survey. Remember, all the resources I've shared today can be found in the notes section of this slide deck. Please visit doe.in.gov/standards/mathematics and click Professional Learning to access the link to the presentation and other Summer Learning Series webinars and professional learning content. My contact information is also available. Feel free to email me or tweet at me anytime. I'd be happy to help. Thank you so much for your time and your dedication to Indiana students.